Hello students, today we are going to discuss a very important gas law, that is Charles law. So let us discuss the statement of Charles law. So statement of Charles law states that for E at constant pressure, first of all we have pressure is equal to constant. Pressure is equal to constant. Okay? So at constant pressure, for each degree rise in temperature of ideal gas, suppose the temperature of ideal gas rises from T1 degree Celsius to T1 plus 1 degree Celsius. So for at constant pressure, for each degree rise in temperature of ideal gas, the volume of ideal gas increases by 1 by 273 times of its volume at 0 degree Celsius. So suppose the volume of ideal gas at 0 degree Celsius is V0. So the volume after T1 plus 1 degree volume at T1 plus 1 degree Celsius is equal to V0 plus 1 by 273 into V0. This will be the volume after 1 degree rise in temperature. And suppose the temperature rises by T degree Celsius. So the volume will be V0 plus V0 volume at temperature T Vt is equal to V0 plus V0 into 1 by 273 into T. This will be the volume at temperature T after temperature increases by T degree Celsius. Now simply we state Charles law as volume is directly proportional to temperature at constant pressure So V is equal to K into T, where K is a constant. Let K be constant. So the plot of V versus T is a straight line with intercept 0. So this is V versus T plot. Now since V is equal to Kt, where K is a constant, this implies if we put V1 is equal to K T1, this implies V1 by T1 is equal to K. In the same way, V2 by T2 is equal to K. So V1 by T1 is equal to V2 by T2. So this is an equation. Also, if we draw V versus T plot, suppose we have three plots. Here pressure P1, here pressure P2, here pressure P3. So if it is asked that what is the relation between these pressures, so first of all draw a straight line at a temperature. Let's suppose its temperature is T1. So at this temperature the volume is V1, here V2 and here V3. So temperature is constant. So we know that from Boyle's law, pressure is inversely proportional to volume. So here volume will be greater, so pressure will be less. So P1 will be less than P1, P2 and P3. Here pressure is greater than, volume is greater than volume at pressure P1, but here volume is less. Here volume is less than the volume at pressure P1, but here volume is greater than the volume at pressure P3. So here P2, and lastly which P3 which have lesser volume, have greater pressure. So the order of pressure will be this. Here P3 order of pressure will be this. P3 is greater than P2, greater volume, lesser pressure. So P1 is lesser, and smaller volume, greater pressure. So P3 will be greater. Now if we draw volume versus temperature curve, suppose this curve A, B and C. Here A is the molar mass of first gas, B is the molar mass of second gas, and C is the molar mass of third gas. Now if it is asked that what is the relation between this A, B and C, what is the relation between this A, B and C? So let us discuss what is the relation between these A, B and C. We know that PV is equal to nRT. Here we have plot between volume and temperature. So volume is equal to nR by P at constant temperature, at constant pressure. This will be the relation. So we write it as Y is equal to mx. Here this is the slope. Here this is the slope. So write this equation for A gas. So we have slope for A gas will be Na into R by P A. Slope for B gas Nb into R upon Pb, and slope for C gas will be Nc into R by Pc. So we have seen that the plots are at A, B and C. Here A have greater slope. So here we see this quantity for A will be greater. This quantity for A will be greater. This implies obviously Na will be greater for A. Na will be greater for A. Since R is constant, so Na will be greater for A. Na will be greater for A. In this way, Na is greater than Nb is greater than Nc. Since slope for A will be greater than slope for B, and the slope for C is smaller. So in this way Na will be greater. So we know that Na is the number of moles of A, Nb is the number of moles of B, and Nc is the number of moles of C gas. So we know that number of moles is equal to given mass of gas upon molar mass of gas. So this will be greater for A, also given mass of B upon molar mass of B, also mc given mass of C upon molar mass of C. In this way, so we have to check what is the order between the molar mass of A, molar mass of B and molar mass of C. So we have order like this. For number of moles, since this is the given mass upon molar mass, number of moles, that is Na. Now if order is Ma by molar mass of A is greater than given mass of P upon molar mass of P is greater than given mass of C upon molar mass of C, then here Ma will be greater, but for being this quantity be greater than other two, this quantity must be small. So, and for this quantity be smaller than these other two quantities, this quantity must be very large, so that the overall quantity may decrease. In this way, MC is greater than MB is greater than Ma, that is molar mass of C is greater than molar mass of P is greater than molar mass of A. So in this way, molar mass of C is greater than molar mass of B is greater than molar mass of A. So in this way, we can solve out the question through V and T curve. Thank you very much.